on today's lecture. I hope that we've got my students here, which are students from monetary economics. And today we've got special host on our lecture that is Professor Ivan Mihajlovic. So I'm sending a greeting to him right now, and he will be talking about the impact of the energy consumption and the ecological footprint on COVID-19 number of cases in 72 countries. So during his speech, you have the ability to answer some, put some questions on our Professor Ivan Mihajlovic. So you can be free to use our chat, okay? And after his speech, he will answer your questions. So I hope you enjoy today's lecture, and Ivan Mihajlovic can speak right now.
Thank you very much. I hope that you can all hear me. As my dear colleague introduced me, my name is Ivan Mihajlovic, and I am a professor of University of Belgrade, Technical Faculty and Board. Today I'm going to speak about the impact of energy consumption and the ecological footprint on this new pandemic that we had, that is the number of COVID-19 cases in 72 different countries. As you can see on this first slide, this is the joint research of mine and my colleague Radmila Jankovic. She is actually my PhD student. So basically the research that I'm going to present today with the results are the results of the research for her PhD thesis, where I'm mentoring her. And I hope that it is going to be interesting for you because you will see that we have tried to make some connection in between consumption, in between different factors that are influencing the ecological footprint, and with the number of cases which are recorded for the COVID-19 pandemic. Also, I must notice that the research that I'm going to present today is partially financed by the Ministry of Education, Science and Technology of Republic of Serbia. So it is part of one grant that we received for our research. So let me start shortly. As I said, I'm a lecturer at Technical Faculty and Board. Technical Faculty and Board is part of University of Belgrade, and Belgrade is the capital of Serbia, and our largest university is University of Belgrade. And my faculty, Technical Faculty and Board, is the only one which is located outside of Belgrade. It is located in eastern Serbia, in city of Bor, and there is a reason for that. This is because we have very large industry capacities here. The city of Bor is famous for producing copper, and it was one of the largest copper smelter and mining facilities in Europe. Now it is also still a very great copper producer, and one of the biggest in this part of Europe. And as such, it is well industrial developed, but also you can see that in such cases, besides many positive things, usually industry can bring some other ecological problems. And I'm going to present today the factors which can influence the ecological footprint. So let me shortly start. First with the introduction of the research. We can all say that during the history, the human activities were always directed into direction of controlling the environment, using the resources to produce goods and to allow us to enjoy the commodity of everyday life. But besides production and everything that is good and positive with this, our activities are always influencing the environment in such a way that the resources that we are using are limited, and we are somehow going into direction that some of the resources which were available in the past, in the future are going to be not that available for our kids, grandkids, and so on. So basically, what is important today, and you will see with the results, it will become more and more important, is that we learn somehow to use just the resources that we have available for us and not to use the resources from the future generations. Because at present, we are using much more resources than is required for our everyday life because of our commodity and the factors that we have used to live in the way that we are living today. And this way we are increasing the pollution of the environment and exhausting some of the resources which were available in the past and which are not going to be that much available in the future. So basically, if we consider the Earth as one closed system, this is something that we have available, and we still do not use anything from outside of our planet. So basically, we must preserve the resources of our planet if we want to live in sustainable society, and if we want to live in sustainable conditions and to live the same conditions for the future generations. Here in this research, we were dealing basically, we started our research with ecological or environmental footprint. And we wanted to see how the environmental footprint can be calculated and modeled and how it can be predicted. We wanted to develop a mathematical model that can help us to predict ecological footprint and to see in which directions we are going. The reason for this is because everybody is saying now if we switch to renewable resources, we will be able to stop the increasement of pollution, and we will be able to facilitate the ecological footprint which will be sustainable. But nobody is saying what should be the proportion of renewable? Is this that we should completely switch from non-renewable energy to renewable energy, or there should be some proportion of both sources of energy today to be able to achieve sustainable ecological footprint? And this is why we wanted to develop this model and to see how the different sources of energy are influencing the ecological footprint, and somehow to calculate what would be the break point, or on which level we should switch from non-renewable to renewable resources to stop the increasement of ecological footprint of our planet. So to be able to do this, we were using, as you will see, different linear and non-linear statistical tools. Also, the model was then fine-tuned using Monte Carlo methodology. And this was our first part of the research. But during our research, which started a few years ago, we were faced with this pandemic. And somehow in the middle of March, I believe it was the 15th of March, the emergency state was pronounced here in Serbia during the pandemic crisis. And in those days, we wanted to see, is this number of cases, which is still increasing all over the world, somehow connected with these factors that we were already investigating in our research. And this is what motivated us to do this kind of the research, to see is the number of cases of COVID-19, is it connected with ecological footprint values in different countries. And we were using the database that we already had for these 72 different countries from the ecological footprint network, and compared this database with the base which is available on Google and which is recording the number of COVID-19 cases. So to start with this, first of all, I want to introduce the ecological footprint to you, to see what actually it is. One of the largest networks that is dealing with measuring and calculating the global footprint is the Global Footprint Network. And it says that ecological footprint is the only metric which can measure how much nature we have and how much nature we use. And basically, ecological footprint accounting measures the demand and supply of the nature. Here you also have a link to this network where you can see the results for all of these 72 countries that I am mentioning here, because the measurement started and the calculations for these 72 countries, for some of them, starting from 1965 until today. And you can see the results which are available on this link. Now I'm going just to present what influenced the ecological footprint for each society, for each country, and also influenced the global ecological footprint. As already said on the previous slide, where it says that ecological footprint is accounting which measure demand and supply of the nature, let me see what is on the demand side. On the demand side, we can actually see the assets that population requires to produce and to absorb the waste that is generated through production, and especially it is connected with the carbon emission. Actually, on the demand side, we are using the resources to produce any of the products that we are using. And for example, if we would only do the agriculture and producing just the food from agriculture, then it would be easy to calculate the ecological footprint of production, because it would be measured by the number of hectares that we are using to produce crops, the wheat, corn, and everything else. So basically, to calculate how much we need the land to produce the food, it is easy. But we all know that we are not producing just the food. We are producing all other types of products, and for all of these products, we are calculating the ecological footprint. But the measure of ecological footprint is the hectares. So basically, for each of the products that we are producing today, we are using some conversion factors, as you will see in some of the equations on the later slides, to see how much actually of the land we are using to produce that good. For example, if you are producing, I don't know, car, using adequate calculations and adequate calculations factor for conversion, you can see how much of the land is required to produce this kind of product, which is a car or automobile. So for each part of that product, we have calculations how much is the equivalent of land used to this product to be produced. On the other hand, during the productions, beside this final product, we are also producing the waste, which can pollute the land, the air, or the water, the rivers. And this also should be calculated in this entire ecological footprints, mostly through carbon dioxide that is emitted during the production, because it is the most, I would say, famous measurement of ecological pollution that is a result from the industry. So basically, all of this is used on the demand side to see how much of the land available is used for any of the products to be produced. On the supply side is the capacity to recover. For example, as I said in the beginning, if you are using the land for agricultural production, every year it is recovered after the agricultural production, and you can reuse it for another year. Also, all the emission of carbon dioxide and other pollutants which are emitted to production of any other products, especially carbon dioxide, are also eliminated. As we know, for example, in Amazonia and other parts of our Earth, we have large forests which are actually dealing with purifying the air from this carbon dioxide in amount of their capacity. So all the Earth is recovering its own resources on its own availability. it can only require with some limited potential. It is not unlimited, as I already said. So on the supply side, we have actually the biocapacity of Earth to recover after us using the resources for the demanding the resources of Earth to produce anything that we want. And on the other side, we have the recovery and the capacity of recovery as biocapacity of Earth to recover from our activities. And if it is if we calculate and demand and supply side, and if it is on zero, then demands are higher than our supply, than the biocapacity of our region, then we are creating the deficit. Actually, we are using much more resources than are available. And basically, this is what the ecological footprint is calculated for any of the countries. How much are we using of the available resources, and how much is the biocapacity of that country to recover from this production that we are organizing there. And if it is negative, then we are using much more resources than available. And you will see most of the well-developed economies and the countries are in deficit. They are using much more resourcing than available, and our entire planet is actually in deficit, as you will see now. So basically, in a long period of previous years, we are in this deficit, and we are using much more than is available for us. And it is actually a problem. Besides the problem of ozone layer, besides the problem of greenhouse gas emission and everything else, one of the most important problems that we are going and should be dealing in the future is actually this deficit of resources that we are facing, because we are spending much more than it is available for us, and actually creating this ecological deficit. For example, here in Serbia, each year we consume our natural regeneration capacity during August. So in August each year we have spent most of the resources which can be regenerated here in Serbia, and in the period from August to December we are just contributing to global pollution, because we are using much more of the resources that can be restored in 1 year. And we are not the only country which is doing that. In general, the entire world is in such a condition because we are creating this ecological deficit globally. So today the humanity is using equivalent of 1.7 Earths to provide the resources which we are using and to absorb the waste that we are generating. So it means that if we have 2 Earths, but we have only one, it would be sustainable. But considering that we have only one planet Earth and that we are using 1.7 each year, then we are in this environmental deficit. So this means that it now takes the Earth 1 year and 6 months to regenerate for what we are using in 1 year. And what is this additional 6 months? Those are the 6 months from the next year, and then from the next year, and those are the months that we are borrowing from our kids. So basically we are using 1.7 planets and we have only one, and this is not sustainable. So in the future we are going to face the problem that we are not going to have the resources for normal life, and that the emission that we are creating and polluting the rivers, the air and the water are going to increase. It is not the reversible process, unfortunately, if we don't change our behavior. And this is something that we are facing from the second half of the 20th century, and of course now in the 21st century, but many civilizations that were living before us knew that. for example, the Indians in United States or of America were saying that the earth is not inherited from the past, it is borrowed from our kids or from our children. And they were just using the resources which were required for them to have a normal life and not to produce more than they need. Today, we are unfortunately not behaving in this way. We are producing almost every product in amounts which are much more than we actually require, and we are used to have such kind of comfortable life, and we are doing this by borrowing the resources from our future generation, and this way endangering the human species and its future. So, as I already said, there is this global footprint network, which is dealing with the ecological footprint. And you can see here, it is from their web page. This country, which are colored in red, are those which have ecological deficit, that are using more resources than available. The countries which are green are those which do not have deficit, and they are using just the resources required or even the less than required resources. But as you can see, the number of these red countries is much larger than number of these green countries. In this way, also on this network, we can see what is the ecological footprint for any of 72 nations for which they are calculating and collecting the data. So, for example, the data was not updated after, for example, for Serbia after the year 2014, but this data which is available for the year 2014, you can see that Serbia, as I already said, is in ecological deficit of 1.4, so our ecological footprint is negative, because our biocapacity per person is 1.6 green hectares, and ecological footprint per person is 3 green hectares, so we are in deficit of 1.4 green hectares. Also for Czech Republic, you can see that also you are in deficit. This data that was available was for the year 2016, and you can see that your ecological footprint is 5.6 green hectares per person, and that the capacity of your country is 2.6 green hectares per person, so you are in deficit for 3.0 green hectares per each person during each year. So we are both in the same conditions, but most of the world unfortunately is, and we are using much more resources than it is available for us or can be regenerated in a year, and we are all contributing to this global ecological footprint with our behavior. The ecological footprint, as I already said, can be calculated for any product, but also it can be calculated for any person. There are the calculations where everybody of us can calculate our own ecological footprint and to see is our behavior sustainable or not. And most of us are actually creating the deficit, as we can already see here in average. And if we decide to change our behavior, maybe in the future the situation can be changed. But as I already said, in our research, we were dealing with these energetical sources to producing electric energy, and to see how much of these resources are influencing the ecological footprint of our nations and of entire world. So actually, as I already said, the problem is existing in many countries. So I already indicated here two most developed economies of the world, for example, United States and China. And you can see here the problem with the United States is in constant ecological deficit, because they have large ecological deficit per person. It is 4.8 green hectares, and it is like a constant starting from the year 1961 when they started calculating this until today. The most fastest developing or accelerating development is recorded in China when it comes to ecological footprint. You can see that in the beginning, in the 60s, they were actually green country and they had biocapacity larger than ecological footprint. And you can see here in the beginning, it was green. But then, starting with economical development and industrial development of that country, they have almost exponential growth of their GDP, but it is followed with almost exponential growth of ecological footprint. And it haven't stopped. So actually, maybe in the future, they are going to contribute to ecological footprint even more than United States, because you can see in the case of United States, it is a kind of the constant value and it is not increasing. But in China, it has the exponential growth, and considering that it is per person, if you multiply this with number of people living in China, then you can see how much they are contributing to ecological footprint. I would say much more, for example, than United States, because it is much larger country with larger number of people living there. So in this research that was published by our colleagues, we saw that the problem of ecological footprint is actually connected in with some authors with GDP. So you can see here on this diagram that they were comparing the ecological footprint with the GDP of countries. And you can see that some countries follow the pattern that increasing their GDP is also leading to increasement of ecological footprint. And somebody would say, yes, we are increasing the pollution, but on the other hand, the living standard of our people also increase, and this is the price which we have to pay. But on the other hand, we have the countries also which are not increasing their GDP, but they're also increasing the ecological footprint. And those are the countries which are actually not well developed economies, but are spending a lot of non-renewable resources for heating, burning the woods, burning the oil, and so on, and actually not having the large GDP, but resulting with the large value of ecological footprint, which contribute to cumulative value of global ecological footprint. So each country can be allocated here in the way that they are comparing the GDP to ecological footprint. And this is actually what motivated our research to see is the ecological footprint, is there potential to model the ecological footprint using the GDP as here, but also using the other important factors, and to see if it can be predicted. Because on that network that I was presenting, they are just recording the data and calculating the present value, and we wanted to go the step further and to develop the model which can be used to predict the ecological footprint. And one of the factors that we were analyzing is actually the GDP, but also the energetic factors, as you will see. And how do we measure the ecological footprint? I already said that for measurement we have to use the data that we have for global production and for annual production of the economies, but also to see how much of the land they have available for restoring the resources after the production. And this idea started for this measuring and was introduced in 90s by this group of authors that were the first that were dealing with this item. And there are a few different types of footprints that can be characterized in the recent literature. But for the estimation and for calculation, the major consumption categories of ecological footprints are categorized as carbon, food, housing, goods and services footprints. And maybe the most famous one is carbon dioxide footprint, which is now very popular, and there are a lot of articles which are published with this. But also, as I already said, we can calculate the ecological footprint not only for carbon dioxide, but for any product that we are producing today. So some of the calculations which are available from the literature are here, where we can see the actual equations that we can use to calculate the ecological footprint, where we have this p-value that represents the estimate of produced products or carbon dioxide emitted during the production. This epsilon n shows the country's average yield for each product. This JF is the annual yield of each product, and as I already said, considering that we have to transfer these values into green hectares, we are using this equivalent factor, which is different for any type of consumption or any type of production. And this is to calculate the ecological factor of production. But then we are not just producing. Every economy is also importing and exporting. And these activities are also influencing our local ecological factor of our country. So in this other, the equation number 2, you can see that on this ecological factor of production, we should add the ecological factor of import, and we should take off the ecological factor of export to be able to calculate the ecological factor of our country or of our economy. So I have given here the example from this publication of a group of researchers that were calculating the ecological factor of transportation, for example. And using the equation that I already presented, this is not for production, as I said there in this previous slide, but this is for consumption. If we are transporting ourselves with the vehicles that are using diesel, we can calculate how much is the ecological footprint of this transportation by multiplying our yearly consumption in gallons of diesel fuel. But with this 138 and 700 British units for energy, BTU, per gallon, and to calculate this with this 19.95 ton of carbon which is emitted per billion BTU, and this is after that multiplied with this equivalent of 1.8 ton of carbon, and you can calculate the ecological footprint for using the diesel fuel in your vehicles for your yearly consumption, for example. But also it can be calculated in personal way. If you know how much your vehicle is using, how much of gallons your vehicle is using of diesel, you can calculate this for your own car, for example, using this calculation. And basically, as I said, it can be calculated for any of our activities, for any of our products that we are producing, for any of our consumption that we have in our everyday life, and to see how much are we contributing to the cumulative or global ecological footprint. And this is how it is presented based on this equation number 2 that we had previously, where we can see that every economic system is dealing with its own production, with its own consumption, but also it exports some of its goods and also importing the goods from the other economies. And as one closed system, it is presented here. So how did we consider in our future research, measurements and calculations and modeling and numerical analysis of ecological footprints, and in which directions we were aiming to go with the research that we have started? As I already said, I'm living in city of Bor, which is a very industrialized city, and in last 100 years it is one of the largest copper production in this part of the Europe. And in the past it was very easy to see who is creating the pollution and increasing the ecological footprint. It was enough to open the window and to see carbon dioxide and sulfur dioxide that is produced, also to see industrial activities and to see how much it is influencing the land of the surrounding, or to see the rivers which are surrounding and any of the copper mines in the world and also here, and to see, yes, they are polluting. And in the past, it was not difficult to detect who is the most polluting creator in your country or globally, because the industries were organized in this way that using resources directly and emitting the pollutants in the air, in the water, and on the earth. But today, with the Industry 4.0, we are all transferring in some other aspect of production. Even here in my country, during the last 5 years, the new installments are created and financed for producing copper, which are actually not emitting as they were in the past sulfur dioxide and carbon dioxide, because it is modern equipment and basically you cannot detect the direct influence to the environment by production activities. And this is all the result of increasement of the use of the concept of Industry 4.0. I am sure that you have heard about the Industry 4.0. This is actually the fourth industrial revolution. If we start with the first industrial revolution, which started with James Watt, who invented the steam machine, and which started the mechanization and the first industrialization in the beginning in the United Kingdom and after that in United States. Then we had the second industrial revolution, which started in the United States in the Ford production factories with these production lines, which increased the mass production assembly line and introducing the electricity to production lines. Then we had the third industrial revolution, which started in 60s to 70s of the last century with development of computer and automatization of production and new ways of marketing and promoting the products globally. Then we have the new paradigm, that is the fourth industrial revolution, which is dealing with cyber physical systems. And if we observe it with more precision, the fourth industrial revolution is actually dealing with structured data with machine learning, with machine-to-machine communication, with cognitive computing, cloud computing, and Internet of Things, cyber physical systems, and everything which is important for our everyday life. So basically it is dealing with digitalization and replacing some manual work with robotization and computer work, and dealing with the much, I would say, cleaner production technologies. So nowadays and in the future, when we completely transfer our production line in this concept of Industry 4.0, maybe there will not be that large emission of carbon dioxide, large emission of pollutants into the water and the earth, and we can say, yes, we are going to stop with pollution and decrease our ecological footprint. But is it really so? All of these technologies in Industry 4.0 are based on one very important factor, that is energy. So all of this cannot work without electric power. And if we produce electric power in such a way that we are using just renewable resources like sun energy, wind energy, or even water energy, it would be okay, yes. Then our production in the future is going to be completely environmentally friendly. But unfortunately, still on our planet, the most of the electric energy is actually produced by using non-renewable resources like oil, coal, and natural gas. So basically, we are trying to present ourselves as environmental friendly society by switching to the industries which are not emitting that much of the pollutants, but on the other hand, in everyday life and also in production and in industry, we are using much more energy than it was used in the past, and the energy is produced from non-renewable resources, which are also creating a large amount of carbon dioxide by burning the coal or oil or gas. So, on the other hand, we are just switching from one source of emission, from one source of pollution to another source of pollution. In the past, the sources of pollution were directly in the industry. Now they are in energy sector, where we are using non-renewables to produce the energy that we consume today. And we are using much more energy, that electrical energy, than it was used in the past, just because of the fact that we are not only dealing with digitalization of the industry with Industry 4.0, we are also dealing with smart environment in our houses. We are all using this concept of Industry 4.0 in our everyday living surroundment, and they are all based on increasement of use of electrical energy. And this is something that we wanted to research. So, the target of this research was not to calculate the ecological footprint of the products, because, as I already said, it is already available and it is already being calculated with this global footprint network, which is recording this for these 72 countries of the world. The target of our research is to analyze its behavior, to try to develop model that can be used to predict how it is going to change in the future, based on the influencing parameters, which are also publicly available. And these influencing parameters you can see here. So to predict the value of ecological footprint, we were using these parameters, which I already said are publicly available on the internet in different databases. So for each of these 72 countries for which global footprint network is calculating the ecological footprint, we were also collecting the data considering the population of these countries, the number of people, and in this population we were diversifying the urban and the rural population. Then, as we were motivated, as I already said, with the research of these other researchers who were dealing with GDP and influence of GDP on ecological footprint, we also wanted to measure, to calculate, and to do the acquisition of data for GDP for these 72 countries, GDP per capita. Also, in the databases which are publicly available for all of these countries, we were collecting the data for energy consumption per person, for electric power consumption, and on the other hand, for electricity produced from coal, electricity produced from hydroelectric sources, from natural gas, from nuclear sources, from oils, and from renewable sources, which including electrovoltage, or the sun panels for producing energy, and wind turbines also for producing the energy as renewable resources. So for all the countries for which we already had this databases with available ecological footprint, we were collecting this data and developed the database that is with the recorded influential parameters in the period 1971 to the year 2014 for all of these 72 countries, and this resulted with the initial database that was consisting of 3,168 data lines for these 72 countries. The data was mostly acquisited from the World Bank, from the Footprint Network, and other available literature and internet sources. And after that, when we collected all of this data, these 3,168 data lines, we wanted to see, are we on the real direction? Can ecological footprint be correlated with this influential factor or not? And this was the initial correlation that was calculated. So you can see here, this is the total ecological footprint. And if we can see how it is, for example, in correlation with number of people, with urban population, you can see a very strong positive correlation here of 0.94. And what is important, it does have statistical significance because this sigma 2 tail is less than 0.05. Then we can see that it is also in correlation with GDP, with positive correlation. Also here we can see that, as we expected, ecological footprint is actually in correlation with the coal that is used for producing electrical power, with a strong positive correlation. So what does it mean? That if the country is using much more coal to produce electrical power, then the ecological footprint, of course, is going to be larger. And here it said that yes, there is a linear correlation in between ecological footprint and all of these factors that we wanted to use for modeling and prediction of ecological footprint. So this says that you can use linear statistics for future modeling. This is one of the indicators that says so. But also we had some discrepancies. For example, we had negative correlation among ecological footprint and the energy that is produced by oil, which we didn't expect. And also what we didn't expect is that non-significant correlation among ecological footprint and production of energy from renewable resources. We were expecting to have a correlation there, and that this correlation is going to be significant and negative. For example, if you are increasing the production of energy by renewables, this should lead to decrease of ecological footprint, but it was not so. And this is because there is in some nations, for example, only 1% of energy that is produced by renewables. So this is creating the discrepancies. So in this case, we decided to develop some kind of threshold limit. So if, for example, in that country you're using less than 5% of renewables to produce electric energy, then we are not going to take into consideration these results, because it is not influencing that much, and this was the threshold limit which we installed. And with this threshold limit, this of course decreased our database to 2048 lines, and of course, considering that different countries are using different kind of primary sources to produce electricity, we had to develop separate databases for each of the sources that we can use to produce electrical energy. So we developed a separate database for coal, for hydroelectric power production, for natural gas, for nuclear, for oil, and for renewables. So for each of these type of energies, we developed the different databases with this threshold of 5% of utilization of different kind of primary sources to produce electrical energy. And for example, in this database that I'm going to use today as an example, the database that is consisted on 1,352 data lines, which is analyzing the influential factors, which are the number of people living in the city, the urban population x1, the GDP per capita as x2, the energy use as x3, x4 energy production from coal, for example, and of course the output variable is going to be ecological footprint of the countries. And these dependencies, if we want to have the statistical significance, is large. And for each of these dependent variables, for example, energy use per capita, we were analyzing for each of the 72 countries, and you can see here that, for example, the Luxembourg is the country which is using the large amount of energy per capita. Also, we have Canada that is also using a lot of energy per capita, United States of America, and so on. For electric power consumption per capita, you can see that interesting situation here is, for example, in Ireland. In the beginning, they didn't use that much energy per electric power per capita, but in nowadays the increasement is enlarged there. Also, we did this dynamic for ecological footprint. How did it change in this period of 1971 to 2014? And you can see here, as we already said, for China, it has almost linear increasement with the increasement of their industrial activities and export to entire world. United States, we can say, is of course is with large value of ecological footprint, but it is somehow constant value. But China is increasing, and it is going to beat United States with ecological footprint values. And also electricity production from coal. We wanted to see how was the dynamics of this. For example, you can see here interesting situation with Denmark. In the past, they were not, in 70s, they were not using that much electricity production from coal, but then in the 80s until the year 2000, they were producing a lot of energy, electric energy from coal. Then after the year 2000, they started to decrease production of electrical energy from coal. And after that, we did again the correlation to see with this threshold of 5%, and for example, for these databases, which is consisted of 1,353 data lines, how is ecological footprint correlated with all of these parameters? And you can see very strong statistical significance here, and very strong, I would say, positive correlation. So if the number of people is increasing in some country, the ecological footprint, of course, is going to increase. Also, we can see here, if the GDP is increasing, this is also going to lead to increasement of ecological footprint, which is of course expected, because if we have more money, we are going to buy more commodities for our everyday life, and this way, with our everyday behavior, we are going to increase our personal and also national, and after that cumulatively the global ecological footprint, because if we have a larger GDP, we are using much more, for example, on electricity, but also in commodity of our everyday life. Also, the energy use in our everyday life is positively correlated with ecological footprint, and electrical production from coal is also increasing the ecological footprint. But after that, considering that we had this statistical significance and large positive correlation, we tried to develop the simple multilinear regression analysis model to predict the behavior of ecological footprint on these input parameters. And you can see that even with this simple multilinear regressional analysis, we received very good prediction potential. The R square was 85%. So basically this model can calculate ecological footprint So if we know in some country the number of urban population, the GDP, the energy use per capita, and electrical production from coal, we are able to calculate ecological footprint of that country with 85% of accuracy, which is not that bad considering that this is the simplest way of modeling based on multilinear regressional analysis. And we saw here that we are on good track, that we are going in good direction with this potential of modeling. So this is the model summary, and this is actually the equation which you can use now to calculate the value of ecological footprint of any region using only these values. But after that we wanted to had a larger accuracy, of course, in our predictions. So after this simple multilinear regression analysis, we tried to develop the model using nonlinear statistical analysis, and for this we were using multi-layer perceptron in artificial neural networks. Artificial neural networks are basically the technology which is nowadays very much used, and it is machine learning technology. It is also one segment of Industry 4.0. It is, I would say, listed in this cognitive computing because it is one aspect of machine learning, and one tools for machine learning is artificial neural networks, which are basically simulating the way how our brain behaves. And here we developed this artificial neural network for our model when we wanted to have the total ecological footprint as the output, and the inputs were, as I said, the urban population, the GDP, the energy that is used, and electricity produced from coal, for this example, in this database. And the functioning of artificial neural network is this way, that all of these input parameters are inserted into the networks, and the network itself is developing these weight parameters, and with these weight parameters each of the input variables is multiplied, and then it is going to this hidden layer, and here in hidden layers they are using the grouping functions, which in this way was sigmoidal function, to process this input data that is coming here, that is input variable multiplied by weight coefficient. And after that, using this sigmoidal function, it is creating the outputs which are now going here to the output layer, and using the same function, these values are also now multiplied with the new weight coefficients here, and it can calculate the output of the network, which is ecological footprint. But to be able to do this, I said it belonged to machine learning tools. The initial database is split in two ways. The first, in two parts, I'm sorry. The first part is consisted, I can see here, with 71. It is usually 70 to 75% of the initial database, and the remaining of the database is using for testing. So to be able to learn this artificial neural network to calculate ecological footprint, we are randomly using the 71% of initial database, which is 967 data lines, and then the network is trained by using different weight coefficients until obtaining adequate value of the output value of ecological footprint, which after comparison with measured ecological footprint is having small error. And after the network is trained, it is going to give us the model. After that, the second part is testing of the network. So for this, we are using this 28.5% of the data lines that we're not using here in training to test how this model can predict the value of ecological footprint. And if we are satisfied with the results, then we can say, yes, we have developed a neural network which can calculate and predict the ecological footprint based on these input parameters. And after we have done this testing, we received better results than in multilinear regression analysis, usually it is so. So we can see here that now we can calculate the value or predict the value of ecological footprint with the accuracy of 97% in this training of our network. And you can see it is very good lined here for all the values of measured and predicted, because here are the total ecological measured value of total ecological footprint, and here are the values which are predicted with our neural network, and you can see it is very high accuracy. And with the remaining data lines which were used for testing, we received this. This is actual testing of our neural network. You can still see that it is still very accurate, 93%. So basically we can predict the ecological footprint of any country based on these 5 input parameters with accuracy of 93%. And this is the importance of the input parameters. And we can see in our model the most important parameter is urban population, then it is the GDP per capita, then energy use equivalent per capita, and electricity produced from coal as the less important, but all of them actually are giving their influence to prediction of ecological footprint of our model. But even though we wanted to test it further, this network, so in the this is the prediction potential, sorry, first this one, the prediction potential was tested in the case of China. So we developed this prediction model, as I said, in 72 countries that we had in our database. But after that, we wanted to test our models, this linear model that we developed, and also this artificial neural network model. And China was interesting because if you remember on the beginning, I said that they have almost exponential growth of ecological parameters. So it was interesting for us to test our models on their data. And after importing the data in artificial neural network and in multilinear regression analysis, we can see that our model is giving very good prediction potential for calculating ecology and predicting ecological footprint. After that, we wanted to do the Monte Carlo validation of the model. And what is the technology of Monte Carlo? For some experiments which you cannot organize yourself. You cannot know in some country how the number of people is going to increase or how much of energy they will use to produce electric power in the future. You can just do the modeling and prediction of these values and not measure this in next 2 years, for example, from now. So this is why we used the Monte Carlo tool to see how each of these input parameters behave. And we saw that in our calculations, we were using these input parameters: urban population, GDP per capita, energy use, and electricity production from coal sources. And all of these input variables were modeled by Monte Carlo to see their behavior and to use the Monte Carlo technology to predict, for example, values of these input parameters in next 10 years. And we started with the urban population. We wanted to see what is the distribution which can explain the change of urban population. And we saw that this is the person-family distribution, which can simulate the increase of urban population globally, but also in any of observed countries. Also, GDP per capita can be simulated with negative exponential distribution. The energy use was for the energy use, we used the Johnson family as distribution function. Also for energy produced from coal, you can also use Johnson family by Monte Carlo as a distribution function. And total ecological footprint also can be simulated with person family with this coefficient given here. And with this Monte Carlo simulation and this distribution, we did a prediction of change of all of these parameters, and after that generating the random values for the future years. And after that we inserted this in our model and tested it again, our production capabilities, and we can see that we obtain very large precision. So the model that we were developed on the parameters recorded in the past, in the histories, can actually be used for prediction of the future value of ecological footprint. And we, after that, have done Monte Carlo prediction of ecological footprint for next 10 years until the year 2029, you can see here, and unfortunately the values are not that great. And you can see here our model is predicting that ecological footprint is actually going to grow in almost a linear way in the future. So basically, if we do not change our behavior, we are going to face large problems, because I already said that we are on this 1.7 factor of using the resources of our planet. And if we increase our ecological footprint this way in next 10 years, I am afraid that even two planet Earths are not going to be enough for our demands, and I am not sure what we are going to leave for the future generation. So actually, this was only, as I presented to you, calculation based on coal that is used to produce electrical energy. We also did similar calculation for oil, for natural gas, and for nuclear energy, and in all cases, increasement of use of these non-renewables is increasing the ecological footprint. If we switch to renewables in the future, then the situation, of course, would be different. But nobody can tell is this possible, because it is not very easy to persuade or to even to finance transition from non-renewables to renewable energy, and I'm not sure that it is possible to completely switch into this direction in next 10 or maybe 50 or more years. So we are going to deal with increasement of ecological footprint in the years to come. But on the other, yes, with these results, we also developed one, I would say, graphical user interface in Python that everybody can use to calculate ecological footprint. So based on this prediction model that we have developed, here we developed this application where you can put the number of people living, I don't know, in the city or in the region, the GDP of the city or the region, the energy use, and how much of the energy they are producing from coal, and you can calculate the value of ecological footprint of that city or that region or the country, based on our model, which I already presented, has very high prediction potential. But then, as I said, during our research, the pandemic started, and we all were facing the new issue, which additionally complicated our lives, I would say. So, as I said, in the middle of the March, we had emergency situation, and didn't have much to do, so we wanted to see, can we correlate the COVID cases with this that we have already done in calculated and prediction of ecological footprint, to see is the number of cases of ecological footprint somehow connected with ecological footprint, and can it be also analyzed in this way. And we use the database that we already had, and we add additional variable there, and that is the number of COVID cases registered and recorded in all of these 72 countries that we already had in analysis. So we started this measurement in April 12 of the year 2020, and we continue with measurements on a regular basis. The available data is on this link here. This is basically the Google tool that is publicly available, where people are recording and giving the data for the number of COVID cases on a daily basis, and they're putting this on the internet. And we started to calculate this value and inserted this in our database. And we can see here, for example, I have chosen this first date, that is 12 of April. After that, I'm just using this randomly selected 29th, 6th of 2020, and a few days ago I did the measurement that is on 3rd of October 2020. And what can be seen here is that there is some kind of pattern. You can see that if the peak was available here in April, there is just a larger but still peak here even today. So the countries that had a large number, they still have, and this is not just the number of people, but this is the number, I'm sorry, the number of polluted people, the number of infected people. This is the number of infected people divided with the number of people living in that country, with population. So it can be compared. This is not, for example, comparing, I don't know, number of cases in China with Serbia, but we are dividing the number of cases in China with the people living in China, and the number of cases in Serbia dividing with number of people living in Serbia. So it is comparable results, and we can see that in those nations that have a large number, they still have a large number even today, and those countries that didn't have that large number, they have this similar pattern that the number is not increasing as a surprise, but they still have a small number. So there is some kind of, I would say, structured behavior of this data, and we also wanted to test this with correlation, and we see that there is a correlation between numbers on different dates. So we can see that there is a pattern of behavior of number of cases in different countries. And we thought, yes, maybe this also can be correlated with ecological footprint. Is the number of cases somehow connected with GDP, is somehow connected with energy use, or the ecological footprint as total? So this is what we did. We wanted to see, is there a correlation in between number of people infected by COVID divided by the number of people living in that country, that is population. And as we can see here, it is correlated only with ecological footprint. So the number of cases in the countries with statistical significance can be positively correlated with ecological footprint. But on the other hand, we already know that ecological footprint is correlated with GDP, with electric power consumption, and all these other factors that we have. So I would say that direct connection exists between number of COVID cases and ecological footprint, but indirectly it is also connected with all of these important factors which are connected to ecological footprint. So if we are using much more energy and consuming much more goods and producing much more, for example, carbon dioxide, we are increasing the ecological factor, and increased ecological factor is somehow connected with increasement of number of COVID cases in our country. I don't know why, I'm not in medicine, but there is a statistical significance and correlation here. So it is not possible to develop good regression and good multilinear regressional model for this, but in these cases we usually are using this kind of structural equation modeling. Because, as I already said, we have connection in between number of COVID cases and ecological footprint. On the other hand, ecological footprint is influenced by all these other parameters here. So in this kind of grouping cases, you cannot use as a prediction tool multilinear regression analysis because there is no strong correlation. Also, you cannot use artificial networks that I was using for ecological footprints, but you can use this regressional model that is done with structural equation modeling, and for these purposes, for example, I'm using Lisrel software that can develop this kind of model. So we can see here it is proven there is a positive connection in between number of COVID cases and ecological footprints of the country, and on the other hand, ecological footprint is connected with most of these input parameters. With some of them it is not connected, with some of them positively, with some of them negatively, but we are basically on a good track here if we want to make this kind of the connection. And after that, we wanted to do additional analysis to see if there is a connection in between number of COVID cases with ecological footprint and all these other investigated parameters. Let us see how these countries can be grouped, because on this previous slide I presented that there is kind of a pattern in the behavior of number of cases in different countries, and we wanted to do clustering. After dealing with the clustering analysis, we have seen that all of these 72 countries can be clustered into clusters. The first cluster is one which is characterized by high values of ecological footprint, GDP, carbon emission, and also it has a large number of COVID cases per capita. The other country is larger. It has 52 of these investigated 72 countries, but this cluster is with the lower value of COVID-19 cases per capita, but also with lower value of ecological footprint, GDP, carbon dioxide emission, and so on. So based on this, we can see that actually electric power consumption and production, carbon dioxide emission, and GDP also influence the number of cases. For example, for GDP, maybe we can have some kind of explanation. We would say that people who have a larger GDP, they have more money and they have much more social contacts, traveling, and so on, and potentially they can be much more exposed to COVID influence than those people that not have that large money living in the country with small GDP, and there can be connection. And maybe this connection also can be related to carbon dioxide emission, because the well-developed countries are having much more industry developed and still producing much more products, and they also have much more carbon dioxide emission, and this way people living in this country are living in well-developed societies with all of this potential for going to much more events and social communication with other people than in a less developed country. But I am not sure how to explain this. Coming from the statistical point of view, the connection exists and there is some kind of the pattern in this behavior. And with this clustering, we can see here which countries are there. So the countries which are blue, here is this cluster 1, which is with larger GDP, larger energy consumption, and larger energy production, and larger CO2 emission. They also have a larger number of COVID cases. The other red countries are those in this group 2, where we have the less number now of COVID cases per capita, but also they are not that well developed when it comes to GDP and other factors, and those countries in cluster 1. So this clustering is proved here for all of the investigated factors, for carbon dioxide, for total electricity production. The clustering is the same among the countries, the electric power consumption, the GDP per capita, and of course the COVID cases. You can see how the clustering is presented here. So to come to the conclusion, I would say that in our research we started and we still are researching the ecological footprint and the possibilities to predict the values of ecological footprint of the nations and the regions. And I would say that we did develop the prediction models which are usable, and that we can calculate the value of ecological footprint of the regions or the cities or the nations based on the modeling that was done on this initial database that were collected globally. But then during our research we came to the fact that it is maybe possible to correlate ecological footprint and all the other parameters that were investigated with the number of COVID cases per capita in those countries, and we did come to some kind of the results which are correlating these facts. Of course, to be able to have some final conclusions, the research have to be continued because the pandemic is still not over, and of course we would have to involve in our research even the people who are maybe dealing with medicine, the psychology, the social behavior, and so on, to be able to have some kind of final conclusions. For now, this is still just the statistical point of view where we found that the correlation do exist, but I would say that what is important is these pessimistic results that we have for ecological footprint, because increasement of the using of the resources that we have available and increasement of ecological footprint is endangering the entire human population, and of course with the increased pollution that in the future that is coming, that our immune system is going to be much more vulnerable, not only for the COVID, but also for the other diseases that are going to appear. So this correlation, in my opinion, is just one example. But if we are using much more that we have of our resources and emitting as much as we do now, or increase to emit the pollutant in the air, water, and the earth, we are going to be much more vulnerable for any infection or for any new disease that can appear in the future. So maybe it is time for entire population to start thinking about changing our own behavior, and after that changing the behavior in our everyday life, or our nations, or our production facilities of entire community that we are living in. And having all this in mind, here, for example, Borin is one small city in Serbia, but we are on regular basis having the educations for our students, but also for high school students and also for elementary students, to teach them what is the ecological footprint and how with their everyday behavior they can influence the decrease or increase of ecological footprint. Also for them we have developed some small applications where they can calculate their own ecological footprints, and in this workshop that we are organizing with these students, they are calculating their own ecological footprints, and after that they have some suggestions how to decrease and how to change their behavior. Maybe if you all start to think in this direction, the sustainability of our planet is going to be larger than unfortunately it is now. So I will conclude now. I'm sorry if maybe I didn't, if I used too much time, maybe I didn't leave enough time for questions, but now I am open for questions. And thank you very much for your attention.
Thank you, Professor, for your perfect speech and very important issue of your lecture. Can you hear me, please?
Yes, I can, yes.
That's fine, that's fine. It is also very interesting for me, I mean, the discussion with the colleagues with other scientific disciplines, because we are economists and you come from another part of science department, let's say. So it is very interesting for me to hear your point of view and what is your research going on currently. So again, thank you very much for your speech. I also think that our students were interested in your issue, because we've got some published questions here for you, and according to the lack of time, I'm afraid that we will be able to to reply only to one of the questions. So because we are, in fact, actually, we are in subject monetary economics, I would like to ask you on some relationship between CBDC, it means central bank digital currency, which is currently or there is currently a huge debate on its creation. And do you agree with this future step of central banks regarding to ecological footprint development? So can we connect our economical issue with your energy one, please? Thank you so much.
Yes. Thank you. It is very interesting question, and as I said, yes, we are very much open into developing interdisciplinary point of view of our research. So all of this, I would say, input parameters that we are analyzing can be also valorized with money. Yes. If we are calculating how much of different type of energy we are using to produce electric power, we can connect all of this type of energy with money, because not all the type of energies are costing the same. For example, why we are still not transferring the production to renewable sources? Because for now, the renewable sources are still not that cheap. You know, you have to invest in the equipment, and the equipment has some kind of amortization, which usually is not that long. For example, for this solar panels, you can use them maybe for 10 years, and after that you must buy the new one, but initial investment is still high in this, and this is why many people are not going in that direction. For example, I know in Germany they have some kind of substitution from the local government. For example, in the region of Birkenfeld and Trier, in this part of Germany, the local government is giving the money for the people to invest in using the renewable resources to produce electric power. And in this region now they are even exporting the electric power produced by renewable energy in total. But in countries, for example, like Serbia, we still do not have this kind of money. We are not the part of European Union and so on. And our national economy cannot invest in this direction. And one of the reasons why we are not using that much renewables is because it is not that cheap. And the coal and oil is still much cheaper. So if you, for example, like economist, could be involved in our research, you can add the value to this, because you can give us the calculations of every type of energy, how much does it cost? For example, to produce 1 megawatt of energy by coal, to produce it by renewable, to produce it by oil, and this can be additional value and additional influential parameter to see. Yes, it is easy to say we should switch to renewables, but who will give us how much does it cost to switch, for example, from producing power from a thermal power plant that is using coal to producing energy to wind turbine? And I'm not the one who can answer on this question, because I'm not in economy, I am an engineer. So yes, there is a place to combine the research, if you are interested, of course.
I believe in it. Okay, so thank you very much for your reply. And I'm afraid that there is time to say hello. There are also some other questions that are placed in our live session. So could I ask you to reply on them after the end of our session? Is it possible?
Yes, it's possible. Thank you very much. Yes.
Very kind of you. Thank you so much. And it was a real pleasure to meet you, even though it was online. So I'm very grateful that I had the ability to meet you.
Yeah, thank you. The pleasure is mine.
Goodbye.
Bye.